Okay, so today we're going to talk about minimum spanning trees and we're going to introduce you to two algorithms. But before we do that, I want to recall what a cycle is. And a cycle is a walk that begins and ends at the same vertex. So for example, if I would go from A to B to F to C back to A. So A, B, F, C, A, this is what we call a cycle, goes around. Okay, so we can also have what a tree is specifically a connected graph which has no cycles. So what I could say here is I could go A to B to C to E to D. That there, A to B to C to E to D would be a tree. Okay, as would also, I could have also just have done a scenario where it was like A to B, B to F. That is another tree. And I could even include E if I wanted to. So there's lots of different things that are trees, but there are no cycles. And that's the key to a tree. And now if we want to talk about what we call a spanning tree, it is a special kind of tree because, well, so far all the ones that I've shown you are subgraphs of this full graph. And a spanning tree is another subgraph, which is a tree, but it contains all the vertices. So I could, in theory, there's lots of different ones I could start at C and go F to B to A to D to E. That is a spanning tree. Or if I wanted to, I could do a scenario where I go from A to F to C to D to here. All the vertices are covered, and so this also is a spanning tree. And so each graph has multiple versions of a spanning tree, but what we want to often do is we want to find a spanning tree, a minimum spanning tree. And so imagine that these are water lines going from house or from room to room to room to room to room in a house. And these are the number of, let's say, feet for our American viewers, feet between each room in the house. And so if you're going to want to connect these all by water mains, you want to find the shortest path through them all so it's most efficient and costs you less money. And so that's kind of the idea of this minimum spanning tree. It looks for a circuit through all the vertices that is smallest. And that usually means cost. And if you think about Google Maps or road maps kind of thing and how they choose their path, this kind of idea is inherent within there because we want the shortest distance from point A to point B, and these could be roads. And there's an introduction to spanning trees.